All right, so we're starting into chapter 13 today, which has two big ideas in it, experiments and observational studies. So I just wanted to share a line from an article I found from 2007. It says ADHD linked to lead and mom smoking. And it says a mother smoking during pregnancy and exposure to lead significantly increases her child's risk for developing attention deficit hyperactivity disorder, say researchers. This is what's referred to as an observational study. We're used to talking about experiments in your science classes when the scientist gathers a group of people and says, you're going to do this, this group will do this other thing. But in an observational study, the researchers do not assign the choices. They simply observe them. So if we're talking about a mother smoking during pregnancy, this is an observational study because the mother is the one who's deciding to smoke or not. There was not a scientist who came along and said, dear mother, future mother, would you please smoke while you're pregnant? Right? We just don't do that. So that's what makes this an observational study. Now, the most important thing for you to know about observational studies, they cannot prove cause and effect. Cannot. We cannot say that mom smoking will cause a child to get ADHD. So why do we do observational studies if they're not good to prove cause and effect? Well, we do them when an experiment would be what we call unethical, right? Not moral. It would not be okay for me to gather a bunch of women and assign some of them to smoke while pregnant. We know that smoking is bad and will cause health problems. So instead, I let the women choose, right? Mother chooses whether or not to smoke, and the researcher, the scientist, simply observes what happens. There are actually two different kinds of observational studies, so I'm going to define those for you. The first is called retrospective. That's when we identify subjects and we collect information about their past, so what's already happened. I remember this one because retro reminds me of those things that are cool now, but they're really old. And the second is prospective, pro, like looking forward. We identify subjects in advance, so I've picked out my people, and I'm collecting data about what's happening right now. So if I get them involved in some sort of study right now. So let's go ahead and look at two different examples of those. Example number one, a recent study declared that people who go to church have longer life expectancies than people who don't go to church. Okay, we can argue whether or not that's true, but what I really want to focus on is what kind of study is this? So I think to myself, would it make more sense to maybe identify people, see how long they lived, and then look back into their past to see if they went to church? Or would I identify people now, whether they go to church, don't go to church, and then follow them throughout their lives and see how long they live? Well, both would work, but the one I've described, the prospective, if I'm trying to follow these people throughout their whole lives, I, the scientist, might die before they do. So I don't think this is a very practical thing. This study would have been done retrospectively, meaning I would probably find people who've died. I would see how long they lived. You know, here's Bob, may he rest in peace. He was 87 when he died. And then I'd look back into his past. Did he or did he not go to church throughout his life? Okay. And then I'd compare that to, you know, Bobette. And I don't know, Bobette was 53 when she died. And then I look back into her past. Did she or did she not go to church? So that sort of thing. Example number two, in a test of roughly 200 men and women, those with moderately high blood pressure did worse on tests of memory and reaction time than those with normal blood pressure. So in this case, we would have done a prospective study. I would have gotten some people together, right? Some of them have, it looks like, high blood pressure, and some have normal blood pressure. As a scientist, I have no control over that, so I'm simply observing what happens to them. So I'd find those people, and then I'd watch them now. Okay? I watch them now do a memory test and see how they do. I watch them now, some sort of reaction time measurement. So I'm gathering the data now. So that's kind of that contrast for you. So then the question becomes, all right, Can I prove that going to church causes you to live longer? No, I can't prove that. I didn't do an experiment. I didn't gather 100 people, say, you 50, you're going to go to church every week for the rest of your life, and I'm going to see how long you live. Other 50 people, you are forbidden to set foot into a church, and then I'm going to see how long you live. We don't get to do that. That's unethical. So that does mean I can't prove going to church causes a person to live longer. There might be another explanation. Can I prove that high blood pressure causes your memory to be worse? No, of course not. There could be something else. Think back to our discussion when we were learning about linear regression, right? And there was maybe a relationship between ice cream and drownings, right? Those are things that come from observation. And just because we saw some sort of relationship did not mean one caused the other. There was another explanation. Like in this case, it was heat. We call those lurking variables. And that's what we could have here. Either of these situations, there could be a lurking variable. Because we're not doing an experiment, we're not keeping track of everything that's happening, we cannot prove cause and effect. There might be another